Okay, this is number 2A from section 14.4. You're given f of xy equals x times the square root of y, and at the point 1, 4, you're asked to explain why f is differentiable, and then you want to go ahead and find the linearization of f. So, first of all, to explain why f is differentiable at the point 1, 4, take both partials. The partial derivative with respect to x, that's going to be just the square root of y. And take the partial derivative of f with respect to y, and that's going to be, well, if you think of y, square root of y is y to the 1/2, that's going to be x. X is a constant, so it stays there with respect to y. And you're going to bring down the 1/2, subtract 1, so the derivative of the square root of y is 1/2 y to the negative 1/2, which is really times the x in front, which is really x over 2 root y. Now, okay, look at these partials. They are both continuous on their domains, so certainly they are continuous at the point 1, 4. Note, so I'll say this, note both partials exist and are continuous. I'll just say both partials are continuous at the point 1, 4, and thus f is differentiable at 1, 4. We have a theorem that tells us if the partials are differentiable, then f is, if the partials are continuous, then f is differentiable.
Okay, finding the linearization is basically finding the equation of the tangent plane. And the equation of the tangent plane
is z minus z naught equals the partial with respect to x, in this case evaluated at 1, 4, times x minus 1, plus the partial with respect to y evaluated at 1, 4, times x times y minus 4. Z naught in this case turns out to be, alright, just plug in 1, 4 into the original function, you're going to get 2. Plug in 1 for x, 4 for y, you'll get 2. So z naught turns out to be 2. And if you go ahead and evaluate the partial with respect to x at 1, 4, you get 2. And if you evaluate the partial with respect to y at 1, 4, you'll get 1/4. Plug in 1 for x, 4 for y, 1 over 2 times 2, or, well, I'll put it right here, 1/4. So go back down here and plug into the tangent line equation. Z minus 2 equals 2 times x minus 1 plus 1/4 times y minus 4. And if you simplify that, you'll get z minus 2 equals 2x minus 2 plus 1/4 y minus 1, or z equals 2x plus 1/4 y minus 3, but then if you add the 2, that makes minus 1. And just replace z with L of xy, and that's equal to 2x plus 1/4 y minus 1. And that's your linearization.